while our friends are doing some social networking after us, I decided we have some social networking here. So we'll not start the session, but simply those who will speak later on will just tell you something about themselves. So I would invite Julio. Tell you something about you, about your company, and so on.
Okay. Thank you, Domenico. I'm very happy to be here. And I'm glad to thank the organizer and I will try to do very quick and skip some slides because I have so, as you have probably read in my introduction, between the last and this millennium, we have two very important factors.
No, there was misunderstanding. I thought you introduced yourself.
Not the presentation?
No, just for 1 minute that you will tell something about 1 minute, that's all. And then you start to
okay. Sorry. So, my name is Julio Sugi. I'm responsible for research and development in ICTP and actually also president of Trieste Coffee Cluster. That is the district coffee here in Trieste. Trieste is the most important port for coffee disembarking and one of the most important towns in the world for the coffee industry because coffee industry began last century here in Trieste.
Okay, thank you so much.
We need to make a sister city because Seattle has the largest coffee cluster. Yes, students discovered.
Okay. Good morning, good afternoon. I am Giuliano Panza. I'm teaching seismology at the University of Trieste. I have a little group hosted here at the ICTP in earthquake prediction unit. And about if you want to know what my relation with the Academy, I am a member of the Accademia dei Licei and of the Third World Academy Plus, which has changed name now, and of the Academy of Poetry, which was founded by Napoleon at the time.
Okay, now Nicola.
Yeah, hello, I'm Nicola Panger. In this time and age, I should be like an entrepreneur, but I'm becoming an expert on unexpected developments management. I guess like most of industries today, we have to manage unstable markets, unstable financing, unstable economic situation, unstable everything. So we are something between, surfing and whatever, flying constant counts. So that's my job as of today.
Okay,
My name is Nebojša Šanešović. I come from Belgrade, Serbia, from the Vinci Institute of Nuclear Sciences. It is the largest scientific institution in Serbia. Basically, I'm a theoretical physicist, but also an engineer. And I'll be talking about the Tesla accelerator installation, some of the programs that are focused on healthcare. I am a fellow of the Academy, the World Academy of Arts and Science, and also a member of the Board of Trustees of the Academy.
Okay, thank you so much. The lady will be the last one instead of being the first one. Giorgio?
Thank you. My name is Giorgio Fassina. I'm the CEO and founder of Septigen. Septigen is a biotech company developing novel diagnostic devices for cancer early detection.
No. He's the rapporteur. Then you will say something about you like.
My name is Donatella Verbana, and I'm head of the School of Medicine, University of Zagreb, Center for Translational and Clinical Research, which was established 4 years ago. And I worked for more than 10 years, 11 years in the pharma industry. And before that, I was also involved at the university as a physician. So what was my point then? Why I'm so happy to be here? Because I was a professor Mel's fellow and glad that I'm here.
We are good friends. So.
Not only, you're my teacher.
Thank you so much. And the rapporteur will also say something.
Good evening, ladies and gentlemen. I am Enrico Tongiorgi. I am professor in neurobiology at the University of Trieste. I am also deputy rector for public communication of science and member of this academy.
Okay, thank you very much. Now I will invite Fulvio Suggio Di Verani to make his presentation. Thank you.
Mi sono messo in cattivo. Thank you. Sorry for my fast starting before my because I was there short time. Thank you. I go back again to the slide I had before. So during the passage of from last millennium to the next one, two important facts occurred. You probably all know. We arrived at the peak of oil production, and this began to go down, and the speed of population growth, the so-called velocity, slowed down. So these are two very important factors that probably are on the basis of what we live today. Let's come to more closer to my job and the company life. If you look at the company survival rate, you see that very few, if you take an index like the Fortune 500, you see that in 23 years, only parts, only 300 survived today. But if you go to an older index, the Dow Jones, and you go to last century, so it takes 100 years, only one company remains. Probably you know that this company is General Electric. It's very different from how it was in the 900s. Let's go to new products, success probability. You see that if we speak about durable products, in mechanics it is quite high, but in telecom is low. So success probability is measured in terms of permanence to the market of a product. If a product stays on the market for more than 1 year, it's considered a successful product. If you go to consumable, and coffee is inside consumable, like food and beverage, in the state it is 1.5%, so it's very low, much lower than durable. But in Japan, it is a very mature market. You have a success ratio that is 6 per 1,000. That is incredibly low. There are also new critical factors affecting product positioning in the market. The first one is hypersegmentation, and the second one is the shortening of life cycle of products. When we speak about coffee, our main product has a lifetime comparable to the lifetime of the company, so 70 years. Nowadays, if you do a new product, you have only some years. Another complexity factor is the fact that you must have both consumable and durable and integrate this in a system, and integrating also all the intangible components, so pre and post selling, supply service, assistance, training. You see this fact if you look at the patent distribution. You see that until the year 80s, the number of patents on coffee was very low. Here inside you have decaffeination, instant coffee, and all of this inside the industrial supply chain. But in the 80s, it happened that consumable and durable were joined together, and you have this box. Inside this box is espresso, is all the portion of coffee inside, and all multinational nowadays share 60% of the world market, and there is a big fight on intellectual property. So we are not high tech, but we must follow the same criteria that high tech is following. Okay, let's go now on the side of what company believe is going to happen and how must change the habits of the company toward the market. So this is a top of mind survey that has been performed 2 years ago, and you see that on the first place, corporate responsibility is considered the most important driver from the companies. The second place, food and product safety, but at the fifth place, consumer health and nutrition. This was absolutely outside this kind of radar only 3-4 years ago. So let's see on the consumer point of view what changed. This is the traditional way of seeing and considering a product inside a company and designing it. So you have to consider price, quantity, convenience, so only the industrial dimension is considered. But it is for 5 years, no more, that a totally different approach on the consumer side entered. So together with the traditional functional one, price, quantity, convenience, quality and experience and lack of waste entered the mentality of the consumer. And this is for companies a revolution, because whole industrial system is organized around this. And you have to restructure a lot of things. So, we, as ICTP, were very, very aware to the environment and to the energy consumption. So we apply this since 2008. We accepted to share this objective, the 2020 objective. So reduction of emission of greenhouse, consumption of energy, and energy from renewable. And but obviously also other things must be done in order to be not in compliance with this, but with the new perception of consumer. Probably not in every country, but in Northern Europe countries and in some Asian countries, like Japan, for instance. First of all, we look at what is inside our house. So we noticed that CO2 equivalent impact was very, very high for raw materials. So what enters the supply chain? 28% was in logistics, so all the concerned transportation, and only 21% in the plant. But the plant was the most easier thing to attack. So we developed a roadmap, and we are following more or less, but because there are several changes. But actually, we did an agreement with the Environment Ministry, and now we have also all energy that we buy is coming from renewable. But we entered also a new way to change the product design and introducing a dynamic perspective that is called life cycle management. So product is a dynamic thing and must be managed not only during its life cycle, but maintenance operation are different according to the phase in which the product is. But in order to maintain also sustainability, you must use also new tools and optimization tools. You had probably yesterday from Carlo Poloni his speech about optimization, and in fact trade-off when you have to optimize a product, keeping in consideration also the life cycle assessment is much more difficult than it was in the past. Also for very simple product. So in terms of result today, we implemented a photovoltaic plant here in Trieste, saving 500 tons CO2 equivalent. Then we retrieved also thermal energy, saving again another 500 tons CO2 equivalent. So all heated water and heating system are working with the heat that is generated during the roasting process. As I told before, since 2013, all electricity that is purchased comes from renewable sources. We began redesigning product considering life cycle assessment, and we also introduced. We are doing two research projects. One is called NutriArt, the effect of not only coffee, but because it's full of research about the effect on health, and nutrigen, because there are some very interesting fine chemicals in coffee that could help in health improvement. So we are trying to understand what to do in this direction, because the market is requesting this. Okay, so. Last but not least, on durable products, so appliances that we must produce in order to warranty the system, the concept of system, are these two facts. So we have to design to last, to recycle, and to update. Probably after shortening of life cycle of products, we should think about a product that will maintain the shape of the main part and must be upgradable by small improvements. So you don't crash the whole computer, but you keep most of things and just modify what is evolving. The same thing also for coffee machine and for other appliances that now we crash. So in order to reduce and manage better the waste cycle. Okay, that's all. Thank you.
Thank you. May I add that since we're talking about developing countries, what do they get? ICTP is very grateful to Ethiopia and Guatemala because they're producing excellent coffee beans. Correct? If you have just one question that you'd like to ask the speaker now, you can do it. Please. Oh, you have two questions.
One remark only. What you said, those drones from 800, only one company survived. Think about the university. The universities have all survived.
Down there.
Thank you very much. Everybody worry about typically companies, they kind of think they increase efficiency, they rules that they try to offset what carbon. I saw on your slide that you have plans for reforestation or carbon sequestration. Could you say a little about that and how much does it represent in the overall picture?
We at the moment we have contact with some companies for reforestation, and we enter a program that is managed by Salgado in Brazil. But the main thing is try to do a real diagnostic about raw matter, because what we have seen in LCA determination is that it is much different between country to country. Brazil, for instance, has a carbon footprint that is very, very worse than Ethiopia, for instance. And so every country needs a different program. Not necessarily reforestation, because it depends. If they use instead of while in Ethiopia, with reforestation it is much easier to offset, but the problem in Ethiopia is not only to offset but also to minimize the desertification of the area, because in Ethiopia there is the widest biodiversity for coffee. Coffee was originated in the Rift Valley, and in order to not necessarily to offset but to protect the food industry.
We will have to be in London within this afternoon, so if you have questions, please ask him now, because it's in half an hour he will have to leave. No question? One over here.
Yeah. Could you tell us how many companies on the European Stock Exchange survived?
How many European?
Yeah.
I don't know.
Yeah, because it will be a big contract.
Yeah.
Yeah.
Do you have the number?
No, I mean, Anthony Giddens did this work and showing that in Europe the company are not much changes, I mean, they are much more stable, but at the same time they are less innovative.
Traditions are very important.
Yeah,
no doubt.
So the Giddens did this work in late 80s.
I must say that in France and in Italy there are companies that have been 400 years, so very old tradition, but unfortunately there was no stock market, and most of these companies are not on the stock market, so those data are coming from official data, and for Europe probably there is not so long track record. Probably the London market.
Yeah, London market.
Okay, thank you. I have the mic. Okay. The next speaker. Thank you so much. The next speaker is Romero Panza. We have the floor.
Thank you, Mr. Chairman. We will change a little bit topic. I will try to be talking about the possibility to prevent prevention about disasters, and in particular what are called natural hazards. I think that the first problem that you face when you want to do policy development to deal with natural disasters is you have to deal with multidisciplinary studies, and I think that is one of the reasons why we are here in a multidisciplinary academy to touch upon this point. You need elected officials, citizens, and other stakeholders. And the problem requires to deal with two very important but fundamentally different concepts: hazard and risk. Sometimes they are confused, but hazard and risk are totally different things. And since I will be concentrating on earthquakes, I give the example, the definition for earthquakes. The hazard is the occurrence of a natural phenomenon, such as a seismic ground motion, and risk is the probability of any adverse consequence of hazard on humans or their built environment caused by such sporadic events. I use on purpose the word sporadic because I am strongly against the idea of return periods, which is a concept which is associated to earthquake, very physical earthquake, because that is a wrong concept. It is very appealing, but it's wrong. Earthquakes are sporadic. Otherwise, it would be almost trivial to predict them. I will be showing some examples of how this project, Global Seismic Hazard Assessment Program, G-SHAPE, which is based on the idea of return periods, has been giving results which you will see they are very questionable. This is the manifesto of Global Seismic Hazard Assessment Program, and you see that it has all the blessing of all the institutions, UNESCO, SGS, IRB, INDR. All these associations or institutions have approved the project. Nevertheless, in this picture, there is the analysis of the surprises, or in other words, of all the missed events by those beautiful maps that we have seen before. The pink, is it pink? Yes, or whatever. The colored part represents the surprises. Each of these small dots here represents an earthquake which occurred after the maps were compiled. And only this part, the part in the white part, are the ones that were predicted correctly, and all these are surprises seen in different spaces. But all this means that all the events that are falling in the pink part were in fact much stronger than indicated or predicted by G-shaped map. In particular, this is the list of the most disastrous earthquakes, starting from Mugi in India and terminating with Tobu, Japan. And you see that all these events were totally underestimated by these maps. And even worse, this picture gives you the number of victims based on the real fact, the fatalities you see here, and the estimate. You see that in some cases things are not very different, but in Iran, for instance, there is a factor of 2. Here there is not so bad. Here there is an overestimate, but there are cases in which this number, for instance, Sumatra, Madame, and Tobu, Japan, the observed number is much larger than the estimated. It cannot be evaluated because most of the people was just washed away by the tsunami. These tables usually are not very easy to read, and in fact I summarized what I've shown these words, that more than 40% of the 2001 strong earthquakes with magnitude greater than 6, in other words, damaging earthquake, occurred worldwide in the period 1990 to 2009, are surprises for G-shaped maps. And 95% of these surprises are for 242 significant earthquakes with magnitude greater than 7. And all the big earthquakes greater than 7.5 belong to surprises. In other words, contrary to the promised 10% in 50 years, which is the probability with which those maps are drawn, about 40% of the strong events are surprises. So we are off by a factor of 4, and that is not negligible. So after this introduction of critical data published in the international literature, I think we can ask ourselves this question. Do you think that tectonic weapons exist? And the answer is no, but the tectonic weapons do not exist, but there are G-shaped maps which are even worse than these tectonic weapons. And there is another negative consideration that has to be made, because seismic hazard maps based on this method cannot be used to estimate the risk to which the population is exposed to large earthquakes. We have seen it Human losses are vastly underestimated by V-shape, and thus the mitigation measures in areas where large earthquakes are possible may not be based on V-shaped maps. And even worse, the new project, Global Earthquake Model, is on the same wrong track and will be a further example of what this morning was defined a cost of education, of wrong education. To do wrong maps due to the assumption of wrong facts, you get something that is really very costly. So it's not only the fact that ignorance can be a problem, but also to give wrong information is a problem. And we had examples in this case in Italy where people have been under trial for having not being able to give the right information to the population. Now, let me give you some example. The first, I give you just an example about Italy. The Emilia earthquake of about 1 year ago, May 20, 2012. This event is an exception. As you can see from the map, it occurred in a green part, and in every map that everybody can see, you will never put a green in a place where there is a large hazard. In fact, here, the more you go toward red, it's more dangerous, and green means relax and enjoy. And this is the case of the situation of the area where the earthquake occurred in Emilia, and there is a lot of damage occurred there. And fortunately, the damage was not so largely followed by victims, because the earthquake occurred at 4 o'clock in the morning of a Sunday, and victims were just about 20-25 people. Still a lot of people, but earthquakes usually they make much more problems, bigger problems. But they could have been thousands of victims if the earthquake would have occurred at 10 o'clock on a Sunday. Why? Because more than 100 churches collapsed during the earthquake. And if you take just 10 people killed per church, you reach 1,000 easily. So these are the consequences of this kind of approaches. There was a map existing already published in an academic press volume on Advanced Geophysics in 2001, so much before, where it was indicating this region has possible source of earthquake that would generate an acceleration in up to 0.35 G. What is 0.35 G? Is 35% of the acceleration of gravity. Is the way in which engineers or seismologists measure the ground motion. The green of the probabilistic approach belongs to this interval, which is much less, and observed were 0.24, 0.44, so very well in this part. So, you see, it is possible, if you use proper methodology, to estimate more realistic values. And this is important because from an anthropocentric perspective, it is important that the building resists to future strong earthquakes. And when an earthquake with a given magnitude occurs, it causes a specific ground shaking that certainly does not take into account how sporadic is the event, while the probabilistic approach is affected by that. And this means that the ground motion parameters for seismic design should not be scaled depending on the sporadicity of the earthquake, but should go with the seismic history of the earthquake-prone areas as it is natural done if you consider the neo-deterministic hazard approach with scenario earthquakes. Why is that? Well, this is a very simple example. I developed this thing while I was giving a seminar in Tehran a few years ago, and I was asked the question, what would you do if you have two places where the same magnitude 7, but in one place it has a return period and in another place it has a much larger return period? First of all, I told you I don't believe in the return period. The return period frequency of occurrence is a very familiar concept, but it has nothing to do with the nature of earthquake occurrence. So let's say that you have two sites prone to the same magnitude 7, rather rectangulars. So what do? Well, the site where the sporadicity is higher appears naturally preferable for new settlements. If you want to do something new, you go where the sporadicity is higher, where you expect to have this event less frequently. Vice versa, if you want to do retrofitting. So it depends on what you want to do. The same number you have to use in one way or the other. So there is not a single recipe, depending on what you want to do. Why? Because the reference parameters for seismic design must be the same, because we do not know when the period of this wishful thinking period started and when the earthquake will occur. So, if in a region you can have an earthquake magnitude 7, no matter how often, that is your target. You cannot dilute the risk with the sporadicity of the event. And this is again, I'm showing here the comparison, the two maps, and you see where you consider the return period, you have this very nice green thing. If you don't consider the return period, you have this kind of much more conservative approach, and this is what can be done. So, another limit, this is the approach, the same map in D-shape made in North Africa and Spain. And you see how, this is the hazard that defined in some unit. And you see how this hazard is conditioned by these polygons. You see how these polygons are corresponding to each other. So this tells you that this kind of picture is strongly dependent on the input data you use, and this is not the way you can do it, because these data, the input data, by definition, are not complete. This is what you can do with a scenario, and you see that the picture is, you don't see an easy correlation between the picture above here and the picture below. This is the picture of the events, and this is the picture of the ground motion you expect. So, it has been possible to develop a system of computation of these scenarios via web interface, with computation performed on local computer resources or submitted transparently to the user to modern infrastructures. And here you have the example of the input. More details you can have from the presentation in the geography. This is an example of output you can get. Now, let me touch upon the last part of my talk very briefly. Since earthquake can be predicted, but not with precision, in other words, what is written here, earthquake cannot be predicted with precision. This is a very important statement. I have put it in bold because it is wrong to say that earthquake cannot be predicted full stop. It is important to have in mind that earthquake cannot be predicted with precision, but you can do quite a lot with intermediate term, middle range earthquake prediction. In other words, you can have time-dependent seismic hazard. This is the map made in a deterministic way, the one that we have seen before, giving exactly the immediate event, for example, for Italy. And this is what will be the map if we have an alarm of this kind of intermediate prediction in southern Italy. So you see that most of this part of Italy is silent, but the southern part will be covered by some hazard, and the more red, the more hazard. So, based on intermediate term middle range earthquake prediction, you have the possibility to make long-term planning of some prevention and retrofit action to minimize emergency action. Because in emergency, you can do a lot of things, but you don't do things in the right way, usually. The area we have seen before are very large, and there is a complaint about the fact that it is impossible to have practical actions on very large areas like that. But if you limit yourself to the regions where you can expect ground motion that may really create damage, so you go to accelerations in the ground motion of the order of 0.2 g, you see that if you have an alarm in northern Italy, you have this part, what we call northern Italy for, in our definition, which is formally done. in any case. You have a decent region, so you have a very large area about where you don't have to worry too much. If you have it in central Italy, you have this situation, and you have it in southern Italy, the area around it is still quite big, but these are facts. I mean, there is no way in which being nice and making this dangerous area smaller, you do anything good. You may feel better, but it is completely wrong what to do. So, just to conclude, I like to remind you that in 1955, Russell and Einstein wrote their manifesto, presented their manifesto, and the final sentence is, "We appeal as human beings to human beings. Remember your humanity and forget the rest. If you can do so, the way lies open to a new paradise. If you cannot, there lies before you the risk of universal death." This was, of course, dealing with nuclear weapons. There is an organization, recently founded, IS organization, which took the origin also from Issos battle, where Alexander the Great defeated the Persians, where it is clearly shown that the attitude toward T-shaped maps is consistent with this manifesto. In other words, let's try to do something else, and let's try to forget about this probability information that can be very good for insurances, but they are not good at all for human beings. And these are some references that you can find in the presentation, and these are extremely more detailed references.
I must admit I feel very happy because all the speakers have accepted to talk just for the time that has been allotted to them. Very, very proud of it. Also in this case, I mean, he will not leave, but if there is one or two questions, we can take it now. Okay, we'll do it later. Thank you so much. Now it's your time, Andrea. We started this forum with speech by Andrea Vacchia on dark matter, and he will talk again on a completely different theme, bridging the gap between technology and innovation.
Yesterday we spoke of dark matter, and today I will try to tell you about the work I'm doing as a responsible in Italy for our institute, the National Institute for Nuclear Research, for the technology transfer. So dark matter and this work are not unrelated. It is bound to a wave of need of collaborating with enterprise, of justifying the research work, also beside the need of understanding nature, which is the mission of basic research. So understanding dark matter is one thing, but getting soon in the process and possibly parallelly ready to bring developed technology to some social effectiveness, socio-economical effectiveness is another need which is more and more important. I will go quickly through the fact that, of course, I'm going to speak of our institute somehow, the situation of a national research institute in Italy, and I will come to a conclusion through a quick logic. But let me read what was saying Giorgio Napolitano, the President of our Republic, recently. This is a free translation. Investing in research and innovation is a priority for the development of our country. And the primary task for public and private subjects consists in making available adequate resources and instrumentation to face the difficult challenges posed by a widely globalized society. Which this makes an interesting statement. I put challenges posed by a widely globalized society, which means competitivity in terms of technologies, innovation of industrial assets. So this implies a concrete effort in order to get involved in the process of transferring specific competencies from the world of research. This leads to the valorization of technology and methods resulting from the research world, and requires that scientists also get involved in the management of the innovation process. This is the frame, which seems clear, but is all but trivial to be transferred to the research world. My institute, INFN, is in practice a national distributed technology platform. As you see, there are laboratories and sections, not really homogeneously, but distributed all over the national ground. We have 4 big laboratories, one in Catania, one in Frascati, one in Gran Sasso, one in Legnano. And each structure is autonomous in the technology trends. So there are mechanical shops, electronic shops, there is a computing center here in Trieste. We have, besides that, also a computing farm, powerful. So this means this is what we need to be competitive in challenging world of research. And these structures need to be constantly updated, because we cannot allow ourselves to have an electronic shop which gets old, because then we are no more competitive with our German, French, Spanish, or US or Australian friends. And so we need to be at the front edge in this technology. The fact that we are at the front edge in this technology implies that we could participate to some innovation process in many ways. And but it is up to now, as far as our institute, whose mission, I repeat, is basic research, well, we did get some results, but we need to make much more, also clinically. So let me, up to now, what we did is something in order to reach this distance. We have done a list of our laboratories, our machinery, our skills. We have done exposition. We participated in workshops and conferences. We did a lot of catalogs. And all this, up to now, has brought results which should be much better, let me say that. So we need to find a new way. Also, our institute has an evaluation committee, self-chosen international body, and this body, composed by 5 members, recently did this statement about our work. We are still a basic research institute, but the evaluation committee told us the institute has to look at this activity as an activity of technology transfer as an urgent issue coming from the society. So, while recognizing the very high level of research and so on and so forth, expect that some of the technological assets of the INFN should be exploited also for the creation of wealth. This is totally new, no? The society not only asks to basic research to be excellent and unique in research, this time is also asking basic research to be, from the beginning of the process of proposing a project, to start thinking also to the creation of wealth. So there are questions which requires to be considered. What is the long-term vision? You cannot just do daily in the direction of technology transfer. You need a long-range vision, but also you need to make incentives for the researcher. The researcher must be motivated. Up to now, if a researcher spends work in the direction of technology transfer, there is no acknowledgement, so it is not convenient for the researcher to do this sort of work. And so one needs to build. So one has to, this is a long transparency, I will resume it. So now one has to to avoid that the researcher feels as a diversion from the main goal, technology transfer. One is to introduce the concept that a function of the duty of a researcher, even in basic research, is to be devoted in the direction of involving partners from institutions, from enterprises, and do some research work altogether. And encourage the researcher to consider other motivations for the work than pure research. There is must be an institutional incentive and promotion plans for the research. So this is something which we don't absolutely have. So there is no way nowadays to have some motivated involvement in this sort of actions. One is to require researchers who are motivated and capable of looking at technology to do it also from the business point of view. So it's very difficult, and of course one cannot force everybody, but one should allow a knowledge who does this sort of work. I say that because these are the questions which we have to face if we want to be efficient and effective in this direction. We can speak along about technology transfer as we have done in recent years, more than 10 years, but in the end, if we really want to get to be in a position to receive some result, we need to speak openly of this problem. Also, one has to do internal and external outreach actions, which is bound to the question of clusters, which I will mention later. There is another aspect. Up to now, the PhD students have been advised to be monochromatically directed in the basic point of research. This is also in Italy the tradition. Research is a goal in itself, and this is perfectly right. I grow like that. But I have to say that today things are different, and we need to face that, and one has to open the mind, and the students should look at the research experience as a way to attend a broader set of goals, including business development and technological development. So they should be keen to search and to be open to this aspect of industrial collaboration too. So there are many actions to be done. One could also support industrial fellowships. So we did it. We launched around 13 industrial fellowships where we would pay a fellowship to be spent within an industry research laboratory. And the results go exactly in this direction. We had little success, little number of students and young fellows which would look for this fellowship to be spent in the industry. And this is considered as a non-important thing. So there is a cultural change to be addressed. So we also know we cannot do all this work in our own. We need to look in a broader way to the contact with the industry and find a way to help the researcher to get in touch with the problem which needs to be solved. So one of the aspects which has to be clear, to my opinion, but this is open to discussion, of course, is that industry doesn't care about research in this sense. It's more using the result of research for the development. So, but of course, I'm using here a sort of step function, black and white. There are all the degree, of course, of involvement. But I have the impression that when we speak of research in itself, the enterprise is more reluctant to get involved. Like if we have technology or knowledge to propose, then goes more in the development of innovative products. So this is one of the starting points, but we are not far from this. We have many technologies which could be proposed. Now, one other point of view is to try to understand what is the surrounding medium. So we are a research institute, we have our own world. What is the world that should receive our proposal of ability or readiness to contribute to the process? So here there is a study which is quite interesting. Of course, it is related to Italy. And the study is ranking about 200 countries, and Italy comes out 24th. Okay? And research and development intensity is 28th, productivity 19th. So it's not exceptional. Manufacturing capabilities, strangely enough, 36th, territory capability 56th. So not everywhere, but it's not dramatic. Anyway, the conclusion of this, in my opinion, is that our system is ready to interact with the research, needs the contribution, is not self-sufficient, could really profit of the interaction with the research work. There is another way to look to the situation of the surrounding medium where we act, and this evaluation of the regional innovation scoreboard from the European Community. And we see for Italy, but for Europe it's interesting to see. The blue is the innovation leader, also Germany. Green is innovation follower. The best part of Italy is innovation follower. Yellow is moderate innovator, is the rest of Italy, and modest innovator, a fraction of that. You see, it reflects a structure which is known also for other reasons. But anyway, for what regards us, we can again say that our reality is very well ready to get a better interaction with the research system. I want to report here another study. Unfortunately, I didn't have time to translate the table, so I will describe it to you. This is a report on innovation in Emilia-Romagna. This is one of our leader region, especially in Emilia-Romagna. There is the so-called packaging valley, say the automatic mechanics there was the leader in that. So it's significant what comes out from this research done on 1,500 enterprises, looking at the competitive factor in which the enterprise invest in order to get innovation and knowledge. And the first 3 points are formation of perfectioning of the process of production, formation of personnel, and development of new product of perfectioning existing products. So among these 3, at least 2 of them, the second, are fields, personnel formation, development of new products, in which research and enterprise could probably interact. Now, this second table is also very interesting. So which sources the innovative information arrives? And in this table again, we see a very interesting result. And the last possible source of information is the interaction, almost finished, the interaction with university and research institutes. So this is the last voice in this research. It's very interesting. It's very interesting for us. Nowadays, after all what we think we've done in the field of technology transfer, this is today's result. So probably we need a new approach. The new approach, which to me seems very interesting, is this new concept which has been brought ahead by the European Community, is the concept of cluster, powers and engines of economic development and drivers of innovation in operating development. What is a cluster? There is a definition official. It's a concentration of specialists, companies, institutions connected with multiple links. What I see as an interesting concept, and here I close in German with remembering that the time is gone. The cluster is the way to create, before the project, a communal of people which are interested in development of technology. So, the clusters are necessarily regional concepts. So the region, our region, Giulia, will have probably given specialties and will allow the birth of given amount of clusters where research, enterprise, institution can live together before having a specific project. So the cluster is not born because of a project, but exists and allows strategy and allows the creation of a strategy because of the cluster. So this is a couple of more consideration about clusters, but concluding a lot of work from the very research point of view has to be done in order to reach the result to actively participate to technology transfer. Possible strategy, the clustering way, and this will require time. Thank you very much.
We now move to another topic, that of utilization of knowledge to solve social problems. The first speaker is Nicola Banger.
Thanks. I was joking before when I presented myself. Of course, I'm not just trying to read the future and influence stability. I'm actually a managing director of a public listed company located in Trieste. We manage technology for healthcare, ranging from biomedical technology to ICT, electronic patient record, and medicine. But funnily enough, my job in, I guess, the past, 12 months maybe, has been exactly trying to read crystal balls, understand if entire countries will still be able to pay for anything, including healthcare, understanding if, we would be able to keep sort of economic growth, of financing available to companies, and so on. And we are living into this world where the question of sustainability is not, is not becoming more easy to manage, but it is becoming more complex. So I'm trying to bring together this experience in what is finance, markets, and industry, together with what has been happening in terms of technology revolution. And I wanted to talk about the bottom of the pyramid. It's a concept that's coming out of the book of marketing. There's a guy saying, hey, even the poor people in India and Asia and Africa, they have some money. So how can we sell products to these people? And how can they mention? So it's not it's marketing concept. It's not very nice from looking at it from an ethical point of view. The interesting thing, though, is trying to solve the problem of healthcare for people who obviously have no income, and countries which have very little income, to provide the kind of healthcare we are used to. Okay? Interesting thing is probably we will not be able to get the kind of healthcare we are used to in the future anymore in the same, free sort of way. So there is a double movement where you worry, how do I get to countries? Think about the giants. China, the second economy of the world. GDP per head is $5,000. What kind of healthcare can you pay with a GDP of $5,000? I mean, think about that. Plus, China is spending 5% of the global GDP in healthcare. US is 17%. Austria is 13, 14, Germany is 12, 13, France is 11, Italy is around 9. So, Europe, US, the rest of the world, even the one that is growing, India, $3,000 per head GDP. So, think about this. What we're looking at is a situation where cash is issued, and it's an issue for countries, it's an issue for companies. Profitability, and you know, it's not only companies are used to it, doctors are used to it, even my nurses are used to it. I'm still talking about Europe and US. It's not the same, you know, China, doctors and public employees, which are amazingly have an amazingly low pay. And, you know, there is all part of the mechanism of compensation, let's say, for countries. So what does that mean? Developed countries use crisis, cost cutting. I don't know if you're aware, for example, in Italy, public healthcare has cut costs by 10% in the acquisition of anything from outside, products, services. They have a 10% cut. So from last year to this year, they have, you know, they can spend 90, not 100, even for a running conference. And the NHS in the UK has to save £20 billion pounds in a couple of years. So cutting, private players are failing. I don't know if you're aware, but there is a problem of companies closing down. This is, you know, horizontal every sector. But we are in the situation where a lot of healthcare providers and people who are working in healthcare technology are not able to keep up with this kind of crisis. You have public healthcare. Well, guess what? What is happening again across Europe is that public healthcare, you have public hospitals who are going into administration, are losing too much money. You go from southern Italy again to England, guess what? They are firing the management, putting, the administrator, and telling them, well, guess what? You know, we will give you extra fund, but you will have to not to hire people anymore, and so on. So we have a changing climate due to the crisis. We have what I call the cost of success. Europe is wonderful. I mean, we are transforming acute problems. People were dying of heart attack until 40, 30 years ago. It was like a death sentence. We are now transforming a whole set of problems, including oncology, is moving towards being a manageable chronic disease from being a death sentence. So suddenly, we are, not suddenly, but with time, we are also facing the fact that we have been so good in delivering healthcare that there are people living much longer. People with diseases living much longer, needing more medicine, more care, more pharmaceuticals, more diagnostics, and so on. So, here we are. Problem is Europe, advanced countries. Emerging markets is interesting because you look at it from the other way. There are some problems in economic growth as well in the emerging markets. But first, if you live out of $5,000 per year for $3,000 per year, the value for money is a completely different concept. It's very interesting. We have these discussions with people who are discussing about technologies. I'm using biomedical technologies. Now we have these nice German companies which are high quality, come to India and say, listen, I have this wonderful device. It will not break down for 2 years because we have tested it. It has been used all over Europe, in the US, and we can give you the failure rate is almost 0 in 2 years, blah, blah, blah. But guess what? They do these kind of measurements during working hours on a working week in Europe. It's 40 hours per week. Go in India, you buy something, you have a 24-hour per day cycle for 7 days. So it's more than a factor of 3. So suddenly the technology that we have been paying so much, and it's the top technology, is breaking down after 9 months. So different approach. I'm looking at what I'm getting, I'm very careful. I want to pay you. If you say it's 2 years, I want to pay you for the time I'm using the technology. I don't want to pay you to buy the car. I want to pay you per kilometer if you tell me that really, you can do so many kilometers with the car. So, very, very big concentration, very good money, cost control. Systems that are starting from zero. So, not enough acute care beds. There are not enough hospitals. So that's one. Not enough doctors. So below every average of the World Health Organization and so on. Forget about primary care. So you're used to see your family doctor. It's wonderful. On average in Europe, especially if you're living in a big town like Trieste or bigger, you go out of your doorstep, you probably take a bus, do a couple of bus stops, and you go to see a doctor. Well, there are, a couple of billions of human beings that do not get a chance to see a doctor at all, and they might have to do a 200 kilometer or 300 kilometer trip to go to a hospital. So, what is the kind of answer that we are trying to think about? How to change a bit the paradigm in how healthcare services are delivered? Face-to-face, one-to-one, very much personalized. Is this the correct way, and is it a sustainable way to deliver healthcare? This is the question. Do I really need to see the doctor or the nurse? Do I really need to have this kind of personal time and use these resources inefficiently? Well, technology may help us to change the way we look at healthcare. And basically, there are a set of tools that I can use to sort of drive this path differently. So moving from curing a disease to preventing a disease. How can I use omics? And there you have a lot of people doing omics here. So, how can you use molecular biology and all that kind of steps there? Not only to cure, but to prevent, to screen population, to catch diseases before they take place. So, lower cost approach. Instead of managing the disease and having the huge costs, let's say what we can do in order to prevent or avoid, or at least keep the pathway under control. This comes together with the idea that the problem before curing the disease is actually healthcare maybe should be more a business, or title should be how do I keep people healthy, not how I cure people. So, prevention tools, standardized processes. There's a big discussion about how much healthcare has to be personalized versus how much it can be compared to an industrial process, repeatable, quality, and so on. Probably the only way in which we will be able to manage a world of reduced resources, or a world where there are not enough professionals available, is to standardize processes so that we don't need doctors or we don't even need nurses at every step of the care process. But we can train people to follow precise care pathways with a lower cost approach. The last component of all this is information and communication technology. And if you look at developing countries or emerging economies, I'm thinking especially about mobile technologies. So suddenly, you don't need to do a big fixed infrastructure to have people talk to each other. A mobile phone and a mobile phone infrastructure can come at a very low cost. Numbers are mind-boggling. In India, there are about 800 million mobile phones working. And this was the data that I got 1 and something years ago at the telemedicine conference. So I guess we are now probably approaching 1 billion because they were like increasing by a couple of 100 million per year. So there are tools and technologies out there to transform how we deliver healthcare. And imagine a situation where basically you come from having no access to a doctor to a situation where you have a mobile phone and a phone number with a call center answering you when you have a problem. But guess what? This works in both worlds. This works for somebody who has no access to healthcare and suddenly is able to talk about his diseases, or her diseases, and is able to get some answer about what's going on. And is able to do it without traveling, without using expensive office time, doctor time, administrative time. But can be even paid through the mobile phone. Interesting enough, this is something that we could use in a totally similar way in our world. Our world, where 2/3 of the expenses in healthcare are linked to chronic diseases. It's us people with hypertension, diabetes, any kind of cardiology problem, pulmonary problem, respiratory, renal. Well, guess what? Is these people are consuming about 65 to 70% of their sources are generating the related costs. For diabetes, do I really need to see the doctor, the nurse so often? Can I use technology in a way that allows me to keep my disease under control? Well, what do you see is that the mobile phone, the vision set, can become gateways where you connect devices that can measure your blood pressure, your heart rate, and so on. Give you ideas about the correct lifestyle you have to follow. Help you track the activities you could do during the day, your diet, and so on. At a very low cost. It's ICT. Once you do the software programming behind all this, the cost per user is very low. And then you can jump from having an ICT interface, somebody who's, telling you should eat this kind of foods, you should follow this kind of activity, movement, regime, and so on, and have the professional jump in only after the measurements that you have made show that there is a problem with your actually health status. So, mobile, but in general, telecommunication can be used also for much bigger projects. Now, you install technologies. Do you really need everywhere to have specialists? Do you really need to have infrastructure everywhere? Or it's enough to have even diagnostic imaging, ultrasound machines, and so on, without the radiologist or the doctor there, but with the ability, using telecommunication, to work with knowledge centers, knowledge hubs. So the real challenge here is how to change systems in a way to exploit what technology and science are delivering today. And it's major changes. It's a different way in which doctors work, but also in a different way in which patients approach the healthcare system. And probably we are in a situation where my old history professor used to call it the disadvantage of starting early. He was talking to us about the industrial revolution in the UK. You know, being number one in UK, they started 8 years earlier. An interesting development is that maybe, since we have all the existing infrastructure, but China, India do not, they might be able to put in place all this innovation because it's going from zero to something is good. And we might have to learn from those countries in our direction to see if and how we could be able to make sustainable healthcare.
I was lucky enough to witness the early days of this company. 30 years ago, they had 4 employees, or 5. Now I think they are a group of 12 companies, if I was wrong.
27.
27? Oh! I should update my knowledge. So 27 companies with 2,200 people. Okay, 2,000. Okay, fantastic. So they are growing at quite at a speed, incredible speed. And maybe in 2 or 3 years, if we are going to have another 4 with Trieste, you might be a real big world company. May I introduce the next speaker? Ms. Donatella Urbanas. She's coming from Zagreb. I know her since 20 years, if I'm not wrong. Roughly. She spent some time also in my laboratory. So I'm very happy to see her again here as a speaker at this forum.
So thank you so much for the invitation. It's been an honor here and to see you again after so many years. And I'm glad that I can present something that goes together with the job that I'm doing right now, because I'm at the School of Medicine, University of Zagreb, at the Center for Translational and Clinical Research, and this goes really well with the topic that we are presenting today. I've been in the pharmaceutical industry for more than 10 years, and today we are all connected with the pharmaceutical industry again through different contracts, but pharmaceutical industry today is under big pressure. You all know that expectations from the investors have been increased a lot, and the loss of intellectual property rights in the last decade is really significant. In the same time, the complexity of preparing a new kit, a candidate, and the drug at the end has been increased. Still, drug discovery process is a very nice, well-organized process. It starts with the idea. It goes through the basic research, which is very important for the entire drug discovery process. But pharmaceutical industry is willing to contract this part out and to start development from the scaling up. After scaling up and performing safety assessment, the people are finding the first dossier and preparing everything for the clinical trials in men. And in this first phase, everybody is looking for the safety profile, whether the compound is safe to proceed with the second phase of the clinical trials and to see whether the compound is really doing a contract in men. Today, time is money in the pharmaceutical industry, and we are looking into the valid biomarkers already in phase 1 in order to trying to skip this phase 2 study and save some money and save some time for the large clinical trials that are coming afterwards. After that, of course, if everything is okay, then the drugs will go into the regulatory procedures, ask for the approval, and at the end reach market. But to summarize this, development of the drug lasts 10 to 15 years and it's very costly. Today, one drug can cost around $1 billion, and this is the fact. We cannot avoid it. And there is no mercy during this process. At any time during development, one can stop the project. At any time. It can be due to efficacy, safety, other reasons, pharmacokinetics, and commercial reasons. I have here one slide which is basically a comparison why in 90s we had attrition rates of these percentages of the drugs that were failing during the drug development, and what is the situation nowadays, or what is the situation after the discovery of the human genome. If we can see here, it was 12% the reason of attrition due to the toxicology reason. Today, people are very much afraid to put something into development, even not sure 100% that the drug will be safe. So this is one of the reasons why the drugs are failing quite early into the phase of the safety assessment. Another thing which is very important today is that in early 90s, nobody was taking a lot into account commercial reasons. Today, commercial reasons and economic reasons have become more and more important. Another thing which is encouraging in this period is that due to the very well developed predictive tools, we have less drugs that are failing due to the PK and bioavailability. This is thanks to the computer programs and empirical models together. Still, chances for failure during the drug development are quite high, and we know that when the drug cannot reach the market at the very end of the process, this is basically a sign for the pharmaceutical industry that they should go into some mergers and acquire another company, or they will be sold to another company, and this is why we have this situation today in the pharma industry. What is the solution? I will propose here 3 ways how the pharma industry and the medical community have developed the ways how to survive in these periods of transition. First is big pharma will still stay around the treatment, but they have increased their market segment toward prediction, prevention, and of course follow-up. Follow-up is becoming very important today. You all know the story about Viagra, because follow-up is actually following the drug, what is going to the drug after the drug has been put at the market. New indication, new combination are now more and more pronounced and the new chemical entities develop. And another thing which is very important is that pharma is not anymore concentrated around the new medical entities, coming just from the single chemical compounds. They are interested also in the biotherapeutics like proteins and gene therapy, and moreover, the nutraceuticals and biological active compounds from food are becoming important. Prediction, prevention, and follow-up are the segments that we will tackle a little bit more in this translational research approach that I will explain. This new emerging scientific discipline developed together with the pharma industry and the basic research is basically the new communication strategy between the scientists that are working at the bench and the physicians that are working next to the bed, next to the patient. This is actually a new way of communicating scientific evidences and communicating what has been seen from the patient. What is good is that physicians or medical doctor and clinical personnel are not just going through the evidence-based medicine, they are going also to see the feedback obtained from the patient, from the clinical empirical data, from their experience with the patient, from their experience what the people are telling to them, which kind of supplements they are taking, and then coming back to us with information about the new treatments, the new options, new combinations, and we can then try this within the laboratory at the level of the bench, and again try to transfer this over the clinics. Of course, this needs new skills and expertise, and this is good because we cannot talk just about the basic expertise and basic education that somebody is getting. All these things can be learned also through the complementary skills and complementary courses, short specialized courses and short specialized studies are needed in order to develop new scientists and new personnel for the future. Our experience at the Center for Translational and Clinical Research is from 4 years ago. Actually, the center has been established in 2009, together with the University Hospital Center Zagreb. So we are very close to the University School of Medicine and Hospital Center, and pharmaceutical industry at that time was Pliva and Glaxo, but we still have through Pliva, through Teva, who acquired Pliva, through Glaxo and through Galapagos and Delta, a couple of pharmaceutical industries and biotech companies connected with our center. We have a couple of very well-known departments. One of the most known is Laboratory for Mineral and Tissue. This laboratory is actually a leading laboratory in one FP7 project about bone regeneration, and they won $1 billion. We helped them to write this project, and they are now leading the project with 11 different partners in Europe. We have Department of Proteomics. I'm leading Department for Intercellular Communication. We have Department for Functional Genomics, Clinical Trials. We'll try to establish this one in a better shape. We have a very active Research and Technology Transfer Office, and of course the new department is right now ready to be built up, including bioinformatics and biostatistics. The third solution, how to solve the issue with drug discovery and connecting basic research with applied research and coming to the patient as soon as possible, is to adopt this principle and alliance through 4 basic pillars that have been developed in this alliance with pharmaceutical industry and the medical community. Actually, they would like to act through predictive, preventive, personalized, and participatory approach to the patient. What is prediction? So far, prediction has given good results in pharmaceutical industry, in early drug development, because development of many in silico models have saved the time, and time is money, of course, and simulation and tools that have developed a new way of thinking, a new way of producing data have helped later on in vitro and in vivo setting. This has saved a lot of animals for in vivo and pharmacodynamic experiments, and also we were able, by doing some calculation and mathematical algorithms, to predict the right dose for the clinical trials. In silico approaches developed also to assess toxicity are now a very hot topic. I'm sure that Professor Miertoš knows this very well. This is a little bit limited because it's based on the real data, and people should be willing to give the real data in order to build this in an appropriate way. But not all the people are willing to give their data, especially for the compounds they were not successful. And this is the next challenge that has to be overcome. This is prediction and simulation for the clinical trials. Transition on toward the in silico clinical trial could be possible. I think in the near future we will be able really to skip the phase 2 small clinical trial in humans in order to jump immediately into the large multi-central clinical trials with the good biomarkers that will be developed with the phase 1 on healthy volunteers. Then prevention. It's always good to know that the lifestyle is the center of the prevention, and also Elizabeth Blackburn, Nobel Prize laureate, now is doing this huge studies on telomerase activity related to the lifestyle of the people whom they are investigating. And there is a very famous quote by Edward Johnson: "Genes slow the gun, but lifestyle pulls the trigger." So it is important how we eat, what we eat. It is important how we think about life. It is important how we exercise, and this is all under the epigenetics and nutrigenomics. And of course, positive thinking in order to prevent negative aspects. Another thing, what is also important for the prevention is to perform as much possible outreach activities we could. We should design the outreach activities toward the general public, and these are the groups that are of special attention. We are doing quite a good job in Croatia. I think the children are included, the working population is included as well, especially women, businessmen, and elderly people. I know Professor Stavlenic, I don't know whether she is here, she is very much active in this as well. And then personalized approach has been changed in the last couple of years. This has been changed, I think, in parallel with therapy, because the blockbuster therapy is not any longer so often applied. It was very well adopted during the era of antibiotics, where one antibiotics was used for all population. Then the specific therapy has been applied for specific groups, but the people are looking toward the tailored therapy and to get information on one individual. Whether this is good or not, and whether this can give us maximum value for money, has been already proven. And this has been proven in England by this lady. She presented this at the European Perspective of Personalized Medicine Conference 2 years ago. Afterwards, they published a lot of data on this, following patients on a daily basis and filling up the questionnaires, collecting the questionnaires, and trying to get the best therapy for each patient. They have proven that this is the best way how to reduce the cost and how to increase the quality of life and the life expectancy for the patient that have this chronic disease. And active participation, we are trying to involve as much possible patients and people and public into our actions and try to communicate science, particularly basic science, toward the society, and also to communicate with the students who are studying basic science that they should always think about the final beneficiaries. when they are doing their research, they should think how their research could be applied, although doing just a basic research. What is about pharmaceutical industry in Croatia? Croatia is a country with a lot of inventions, but one of the best known invention is the famous antibiotic azithromycin or Zithromax, developed at early 80s. It saved a lot of lives all over the world. It gave us a lot of money, of course, for Pliva, out of the shares. And today we can say that Croatia, although not a very rich country, because we have a very poor, let's say, GDP, has something very special. And this, what is special, is how much we are giving out of our budget for the public health. We are fifth among 66 listed countries. And who are and which countries are there? You see, Cuba is first one, everything is for free there. The second one is Netherlands, then Japan, Denmark, and then Croatia. It's a lot of money for our budget, and I don't know whether we can afford ourselves this, and for how long this will be. And with this, I will finish my presentation.
You do it until June the 30th, probably.
I hope so.
Okay. A quick question, please. Over there, Donatella.
Morally, I'll speak loud. Morally, about confidence there. That makes a really interesting question, because so often in the pharmaceutical researches there's been this kind of phenomenon of diminishing efficacy after release of drugs. And I'm wondering whether these systems have proven to be a little bit more resilient than past systems in terms of post-release results.
Yes, they are looking into efficacy, of course. But what is really disappointing that they have set up such a high endpoint, and the bar has been put so high regarding the efficacy in animal models, which is for me totally wrong, because I don't believe that the animal models should reproduce what's going in humans. And I'm relying more on tissue cultures and artificial tissues right now than on the animals. And I think this should be somehow in balance. This is in balance and should be taken into account once they would like to invest money into new biomarkers. I think having a new biomarker is much better than having efficacy in animals. Because as you said, later on, the efficacy measure in the animals could not be reflected. And if they are just following the biomarkers, maybe it's the better way how to predict the final efficacy once the drug is in the public. It's really
Donna, I wonder whether you might tell just a few words to the audience about epigenetics, which is becoming so important in personalized medicine.
Yeah, and when we were studying many years ago, I remember Professor Miroslav Radman. You probably are familiar with him because he's very famous molecular biologist. He told us there is nothing to do. Everything is in genes. What you have in your genes, this is determining everything you have and how you will live and how long you will live or whatever. And today they know that influencing the external factors and contributors to the epigenetics, which is the external part of the genome information, can prevent a lot of things. Some people could have potential to develop some disease, but on the other hand, if their genes remain silent, which are harmful genes, the disease will not be developed. And today, a lot of money has been put on acetylation of the histamine, and a lot of money has been put also on controlling the thermodynamic capacity of the cell by monitoring the process that is going in the mitochondria. And I think at the end, the question of new antioxidants and new compounds that could prevent this harmful modification of proteins within the genetic material or within the mitochondria could for sure assure us that we could have more life, better quality of life, and less chronic disease than we can get in the past. I am expecting a lot from the epigenetics.
If meditation was made of underlying the difference which exists between individuals. So somebody will react very positively to a drug and somebody else will not. I mean, you agree with this. Okay, we better pass to the next speaker, which is Wojciech Nešković. So we have apparently Croatian, we finally have also Serbian.
I have already said this. I come from Belgrade, Serbia, from the Nuclear Institute, and I'll talk about the Tesla Accelerator installation being a generator of knowledge and innovation, general and especially for healthcare. Tesla is a large-scale facility for production, acceleration, and use of ion beams in science and healthcare. Its construction began back in 1989, on the basis of a special decision of the government of Serbia. With the control of realization of the endeavor, two international expert bodies were formed. However, in spite of all that, the construction was going on with pretty long delays due to the irregular insufficient financing. In 2007, the government of Serbia decided to stop the financing of the construction budget of Serbia and continuing on the so-called clearing debt of Russia to Serbia. In order to handle easier the problems appearing as a result of that decision, we have divided Tesla into three parts. The natural part, the low, medium, and high energy part you hear about that. In addition, we have broadened and strengthened the programs of its use connected to healthcare. These are the buildings of Tesla Institute. And now about the low energy part. It is called PHAMA, it is an acronym, Facility for Modification and Analysis of Materials. It is a user facility for research in the field, as I have said, the modification and analysis of materials with ion beams. The programs of its use are focused on new materials and nanotechnologies. Presently, PHAMA comprises a heavy ion source, a light ion source, and a channel for modification materials. This is the heavy ion source of the electrostatic resonance type, and this is the channel for modification materials. In 2010, the realization of a 3-year contract on the upgrading of PHAMA began. It is based on the above-mentioned clearing debt of Russia to Serbia. The contract comprises the refurbishment of the existing parts of PHAMA and also the construction of an additional channel for modification of materials, the proton cytotron, and two channels for analysis of materials. This is too specific, but let me say this also. The heavy iron source delivers iron beams at the energies of 500 kiloelectron volts. The energies of iron beam expected from the light iron source go up to 30 kV. The cyclotron will enable to deliver proton beams at the energies between 1 and 3 MeV. And the cyclotron should be commissioned very soon in May this year. One of the experimental channels of pharma will be used for development of electrostatic and radio-frequency rainbow lenses, being the novel ion beam optical elements. Our final objective in this direction belonging to the field of accelerator technologies is to develop a new type of linear accelerator, which will be a multiplex of radio-frequency rainbow lenses. This is one of the newest results we have obtained, the special distribution of protons at the initial energy of 10 keV through the radio frequency rainbow lens. The black lines are the rainbow lines appearing as the skeleton of the distribution. These are the analogs of the meteorological rainbow on the different level. The red and green points represent the defocused part of the distribution and the focused part of the distribution. And this part appears as a square-like proton beam form. This is very important because this appearance is the proof that the acceleration process we are talking about is effective. This is the very new result. We can send the last this paper to a journal a few weeks ago. Now about the medium energy part of the it is called the H4 facility, and it will be used for industrial production of cyclotron radiopharmaceuticals, primarily for positron emission tomography, for medical institutions in Serbia. Its main part is the cyclotron giving 18 MeV proton beams. PET, positron emission tomography, is a supreme functional diagnostic technique deployed in oncology, neurology, psychiatry, cardiology, and pharmacology. However, the technique is used mostly in oncology. To determine if a tumor has appeared, if it is malign, if it has metastasized, if its therapy gives results, and if it has disappeared after the therapy. The diameter of the detected tumor can be given several millimeters, very small, meaning that it can be discovered when it is in the initial phase of development and can be cured in the easiest way. The production program of the H4 facility includes radiopharmaceuticals based on the number of radionuclides. These are fluorine 18, iodine 124, yttrium 86, copper 64, and carbon 11 for positron emission tomography, and iodine 123 and iodine 111 for single photon emission computerized tomography, being also functional diagnostic technique, less precise than PET, but very important one. At this moment in Serbia, there are 2 operational PET cameras, and there are plans to purchase another 5 of such cameras. Each of these devices should enable regularly about 1,800 PET procedures per year. In Europe, 1 camera comes at about 500 to 1 million images. This is the whole body PET scan with the radiopharmaceutical based on radionuclide fluorine 18. The malign tissues are designated by red color. You see here the prostate malign tumor, and these are the resulting metastases. This production program was the basis for establishing a program of development of radiopharmaceuticals technologies in the Vinci Institute. It was focused on stations for production of radionuclides and modules for synthesis of radionuclides. Our first result, accomplished in 2002, was the construction of a prototype solid target station and production of radionuclide either 124 or either 123, positive emission tomography or single photon emission tomography. The second result of the program, achieved in 2006, was the construction of the prototype of a module for synthesis of radiopharmaceuticals, sodium iodide based on iodine 124 or iodine 123. In 2008, the program was transferred to the engineering company called Alex Development. It is a small company. The company began with the improvement of the construction of the existing station for production of radionuclides and broadened the program with other radionuclides, yttrium-86, copper-64, and zirconium-89 for positive emission tomography. They also constructed a solid target station for production of large quantities of radionuclide iodine. This is an Alex station for production of radionuclide iodine-124 or iodine-123. Besides, Alex continued the construction of the module for synthesis of radiopharmaceuticals, sodium iodine, and constructed the module for synthesis of carbon acetate based on another radionuclide, R11, also from that. In addition, the company constructed the gaseous target station for production of radionuclide iodine-123, as well as the modules for synthesis of radiopharmaceuticals based on yttrium-86 or yttrium-90. This one is PET, and this one is therapy. This is electron emitter, and on copper-64 and zirconium-89 PET. This is a module for synthesis of radiopharmaceuticals based on copper-64, and its commissioning began 2 days ago in Australia. So far, the company has delivered 42 such stations and modules to various production centers worldwide. This map shows the countries in which these production centers are located. Now about the high-energy part of testing. It comprises the basic cyclotron and its 4 experimental channels. The machine will be able to deliver 38 to 7 MeV proton teams. And the programs of its use would include experimental production of radiopharmaceuticals, research in solid-state physics and radiation biology, and routine proton therapy and eye tumors. This is the basic cyclotron, and these are the fold tips of its magnet. I will see this. Now, a few words about proton therapy. It is a kind of radiation therapy that has proven to be significantly more successful than photon, electron, and neutron therapies of numerous types of tumors. This is especially true of brain, eye, spine, and prostate tumors. This is a consequence of the fact that with protons one can make the radiation dose delivered to ill tissue considerably larger than the dose delivered to the surrounding healthy tissue. These are the dependencies of the dose received by a tissue on the back that is located at the gamma rays, the black curve, for electrons, the yellow curve, and the protons, the red curve. The maximum of the received dose during the protons is called the Bragg curve. This is the position of the tumor. And you can see that the protons, the healthy tissue before the tumor, is radiated minimum. And that the healthy tissue after the tumor doesn't receive any radiation. This is why I can say that proton therapy looks like an ideal surgical intervention in which healthy tissue is not damaged. This kind of radiation therapy does not exist in the region of Southeast Asia. To have proton therapy, you have to have a big facility. With 70 MeV protons, you can cure eye melanoma, eye tumors. But in order to treat the whole body, cancer, whatever in the body, you need a much, much larger machine. It has been proven that proton therapy gives extraordinary results in treating eye melanoma, being a dangerous malign tumor. but more than 95% of such treatments have been successful. The tumor occurs at a depth of down to about 4 centimeters and is cured conventionally by removing the eyeball. The routine proton therapy of eye tumors as a program of use of the ICTP would be going on, as I have said, with 60 to 75 MEP programs. It would be organized by the Vinci Institute and the Clinical Centers in Belgrade. The patients would come from Serbia and other countries in the region. There would be about 100 patients a year. This is an eyeball with a melanoma. Immediately before the proton irradiation, you cannot see, but a large part of the eyeball is and this is the same eyeball 38 months after the therapy caused a significant regression of the tumor. The corresponding increase of the visual acuity was from 20 to 80%. Let me conclude. We have described here briefly the most important programs of use of plasma being a large-scale facility for use of ion beams in science and for healthcare. The program represents an example of effective generation of knowledge and innovations. They include research in material science, solid-state physics, and radiation biology. But the programs also include development in accelerator technologies. However, the largest part of the programs of use of Tesla is devoted to healthcare. It comprises industrial and experimental production of radiopharmaceuticals, primarily for positive emission tomography, and routine proton therapy of eye tumors. We expect the government of Serbia to make the final decision about the financing of these programs in several months. In addition, we have described the program of development of radiopharmaceutical technologies. The program was initiated by the Vinci Institute and continued by Alex Small Engineering Company located in Belgrade. These devices, the Alex products, operate successfully in a number of production centers all over the world.
Thank you so much. If you prepare an appeal to the Serbian government, I'm sure that most of the WAS fellows will be able to sign it.
I understand that, and we have tried many things, and we are still fighting, and we hope something will happen.
Okay, congratulations, actually. Really achieved, optimal results. Okay, the last speaker of this session is here, is Giorgio Fassina, Chief Executive Officer of Septagen, a company based in a science technology park close to Venice.
Thank you, Romeo. Well, first of all, thank you, the organizer, for inviting me here to talk about the subject that is going to collate a little bit what Panger and Vertanek already introduced in depth. I mean, how can we improve handling patients in this aging society? When we think about diseases and we are looking to the incidence of diseases, we notice immediately that cancer is one of the major diseases on regard incidence. Is second to heart diseases, even though in some countries in Europe already is becoming number one as incidence. Why cancer is getting so big incidence? Well, it's a paradox. Cancer is reaching top position simply because, compared to other diseases, during the past 50 years, very little improvement has been achieved as regards the development of new drugs. If we look to cardiovascular diseases, the drugs that we are using right now are very efficient compared to the old drugs used in the 50s. But if we look to cancer, very little advancement has been made. Main reason, cancer is a very complicated disease, highly heterogeneous disease. By comparison, heart diseases are much simpler. We have an additional aspect affecting cancer incidence, the aging of the population. If we compare the average life expectancy in the 50s with the forecasted life expectancy for 2010, 2020, we notice immediately that a huge increase has been occurred during the past 50 years. From 63, 64 years, we are now reaching 82, 84 years. How is this affecting cancer? Enormously, because cancer is a chronic disease, and incidence depends on population age. So with an aging population, we have an increment in the number of cancer patients. How can we handle this big problem? We have seen that it's not easy to develop novel, effective drugs to treat cancer. So the only way we have now to handle the problem is to work on early diagnosis. Many studies, many clinical evidences show that once you are able to detect cancer at the early stage, chances for survival increase enormously. There are, right now, many drugs which are very effective in curing cancer once patient is detected at the beginning of the disease. The problem with cancer is always late stage diagnosis. Well, so we can expect to have an increasing number of cancer patients. We can expect that this increase in the number of patients is going to increase quite consistently. Expenditures for treating such patients. I mean, there are data showing that in 10 years, the amount of money needed to handle cancer patients will double. And we have seen also before, we are facing another big problem, that health expenditure is going to be reduced, at least in Europe. There are countries where this reduction of health expenditure has already started. Italy, Spain, Greece, Portugal. And let's say the national spending for healthcare is around 10% among European countries, 10% of gross national product, which is a huge amount of money. And if we look, to how this money is spent, majority, 62%, is related to hospital activities, handling the patient, salaries for the doctors, and so on. And just a minor fraction is 16% is due to pharmaceuticals and diagnostics. So this is total amount of money to treat the patient once is diagnosed for a specific disease. How much are we spending on diagnostics? Well, compared to the overall, very, very little. Around the European market is 10 billion euros, which is a very tiny fraction of the total spending, less than 1%. We have seen that early diagnosis is a way to cure patients. This means reducing costs. And in this slide you can see an example of an estimate in the reduction of healthcare expenditure by introducing with an individual diagnostic the surveillance of at-risk cancer-risk patients, and in this case cirrhotic patients. I mean, with just 10 million euros per year, you may save up to 200 million euros. How is the industry and also the basic research moving to try to solve this problem? Well, starting from the assumption that cancer prevention is important, in order to prevent cancer, you need to set up adequate screening procedures. To have effective and low-cost screening procedures, you need to measure cancer biomarkers. Unfortunately, existing cancer biomarkers do perform poorly as regard primary screening because sensitivity is very low, specificity is also not satisfactory, so they are very poorly and badly used for primary screening, since the number of false positives and false negatives is going to be too high. So, where is moving the industry and also basic research? Well, we need absolutely to work more in order to develop more sensitive and specific biomarkers, which then need to be validated by clinical studies. These biomarkers should be implemented on platforms which are easy to handle, which are working on just a small amount of material, which possibly may be useful to predict patient evolution and predict patient response to therapy. These biomarkers should work also on platforms amenable to measure many different biomarkers at the same time, because especially for cancer, which is a heterogeneous disease, we need to measure, to evaluate different molecular markers in order to have high sensitivity and high sensitivity. Possibly, these devices should be amenable for decentralized testing. We have seen that this is very important, especially if we want to make accessible to the elderly a screening which is going to be very effective without having the need to take the patient every time to the hospital for the test. So the answer to satisfy all these needs is to combine novel biomarkers and novel methods for biomarker detection, so to develop novel biosensors for point-of-care applications. We are doing some activities in the field. I mean, we are developing novel biomarkers, and we are also developing novel platforms for biomarker detection. In particular, we are developing a biochip intended for primary screening of cirrhotic patients, intended for countries under development where this disease is very important. And this device is going to work with just a small drop of blood. Is going to be read by a very simple, low-cost device who is going to send them the final information directly to the physician for the final evaluation. That's the end of my talk. Thank you very much for your attention.
Thank you very much. If there is any quick question related to this topic, please.
I'm trapped in my chair.
You are most an Italian politician. You are attached to a chair.
I wanted to ask you about the calculations of life expectancy. Some time ago, we analyzed individual census data for quite over a number of years. What we found is what you found is that life expectancy from birth keeps on going up, leveling off a bit. But what we found is that life expectancy from 50 hadn't changed. Now, this was some time ago we did it. My question is, has this trend continued? Because it's kind of important. It's an indication that treatment of things after 50 hasn't had much impact on life expectancy.
Yeah, well, it may be the case. I mean, these are data
Take the microphone.
coming out from the Center for Disease Control in Atlanta and are quite standardized. I mean, the center it's well known that life expectancy is, on the average, going to increase. We can discuss if it is really. How can we really fractionate between different ages this effect? It's true that big improvement has been generated by the introduction of new treatments. New drugs have really extended the life expectancy of these European countries. If you look to analysis in other countries, you see that during the past 50 years, the life expectancy has not increased very much.
Any further question? It's over there.
When to agree that the introduction of more sensitive method for early detection of let's say primary, maybe even submolecular symptoms of pathological changes as a starting point for cancer incidence, very important for more efficient treatment. But even much more important is efficient primary prevention. But efficient primary prevention will require very interdisciplinary cooperation among experts, as well as much better, let's say, dissemination of up-to-date knowledge about real risk factors in the environment connected with our habitat, our diet, etc., and connection of experts and knowledge-based society. And I hope that all of us would like to support this kind of activity because it would be very useful and only as a result of cooperation of experts from different and complementary fields and knowledge-based society, people of different profession, different age group, from different age group, we could be much more successful in the prevention against different kinds of cancer, connected with environmental factors. According to the World Center of Cancer Study in Lyon, more than 80% are connected with environmental factors. So this is a real chance for efficient primary prevention of majority of cancers.
Yeah, I agree. I mean, the problem is that we need really to act now because the major problem is health expenditure is going down, number of patients is going up. The only way that you have to reduce costs is to diagnose at the early stage. So there is really a strong interest, even by national health authorities, to set up as soon as possible primary screening programs in order to reduce the number of patients. For some pathologies, like for example liver cancer, the cost of a liver transplant now in Europe is around 300,000 euros. Will become unaffordable, and we have to die. And so it's true that this area of research has been neglected for almost 50 years. We are still relying on biomarkers discovered in 1960, because this was not a problem until now. Now everybody is pointing attention on biomarkers in order to have early diagnosis, just to reduce costs, not because they care about the patients. Now there is no money, and so.
Okay. So if there is no other question, I will now ask the rapporteur to summarize in 2 minutes what is the final result, the final success of this session.
So thank you, Domenico. If I had known that my duty was to summarize different topics such as earthquakes, cancer, and physics, then certainly I would have never accepted. So now, how to come out from this situation? So, recalling what my teachers told me in all years, that is, start by keywords. So, I collected a series of keywords concerning the session of today, and I apologize already to the distinguished presenters of today if I will miss some important points. So, we started with society, uncertainty, which is linked to a series of I take this. So due to chronic health problems, chronic environmental challenges, then which is linked also to short life of products, of new products in particular, as we have seen for coffee. Then we have seen that these problems are linked also to market instability, and aging society, and cost crisis. Now, on the other side, we have academia. And the keywords, which I find particularly interesting, was
monochromatic research orientation. That was from Andrea Vacchi's presentation. Orientation that leads to expanding knowledge, but also considering that research is a goal in itself. Okay. So, and possibly, but not fortunately not always, to wrong predictive models, as we have seen from the presentation of Professor Panzer. Now, how to come out from this situation? Thanks to innovation, okay, and it is possible. Innovation, it takes advantage from clusters of innovators, new skills in researchers, large-scale facilities, and money, of course. If there is a real exchange of data, in two ways, it is possible that innovative companies accompanied with special policies. You've seen how important is the the government orientation, may propose innovative solutions. For instance, products. But what emerged from all the different presentations is that there is a special need for predictive models. New predictive models, and the point is that we need to achieve, the final goal is a resilient society. This resilient society has the need of sustainable products, healthcare, environment. So this is another keyword. And so flexible solutions, flexibility. There's one point. The point is that instead of analyzing with all the predictive systems, we need to develop better predictive models. In particular to life cycles. Cycles is another aspect, and localized, personalized models to achieve, and this is the conclusion. I have to move to this part of the board to conclude. Predictive, preventive, personalized, participation. Participatory. But instead of the word welfare, I simply put instead of the word medicine, I simply put welfare. In general, it should lead to environmental health
social prevention of problems using more personalized, focused, predictive model in order to have a more participated prevention and share. But in all of this, there is a special glue that needs to be applied in order to connect everything, which is my personal contribution to this panel, which is that's it.
Bravo.
You should sign at the bottom, and I'm sure that these words will appear in the web page of the Academy. Is that correct?
This is all being followed.
Oh, okay. So we ended the session. I hope you will enjoy it. We enjoy it.